today's webinar is called Using Load CSV in the Real World, and I thought the best way to do that would be to download a CSV file from the internet randomly and import it into Neo4j. So I went to data.gov and I went to their data tab, and this is the first thing you see. It's a consumer complaint database, and if you want to follow along, you can by pausing this video and downloading it right here. And that should only take a few seconds. But I've already downloaded it and I've already opened it up in Excel. So today is going to consist of going through this CSV file, understanding the columns, and then I'm going to draw out a data model, and then we are going to write the import query to import it into Neo4j. And this isn't a modeling webinar, so the drawing of the data model is just to help visualize what I want to do. It's not, of course, there's a million ways you can model this data. Some might be better than others. I'm just going to show my plan for today just to visualize the data model so that everyone understands what my import query is doing, hopefully. So when you download the CSV file, you'll first see this complaint ID column, and every row in this CSV is a unique complaint, so every row is going to have a different number here in this column. We have the product column, the product that complaint was about, and here we see a complaint. There's repetition here, meaning complaints can be about products more than once, so there can be multiple complaints about debt collection, for example. And then there's a subproduct that the complaint was about, and then there's an issue that the consumer had with the product, account opening, closing, or management. Clearly there's more repetition here. An issue can be complained about more than once, and similarly for sub-issues there's going to be repetition. So clearly the subproduct is some subset of the products, and then the sub-issues are in this issue category, right? And then we have the date received, the date the complaint was received. And it's important to note here that, I should also mention that I do have some columns hidden. You can see if you have a good eye that I do have columns hidden. We're just not going to be using this today, but you'll see more columns in your CSV if you did download it. So this date received appears to be month, day, year, where the year is this 2-digit number. And you can see right now that if you click on it, it's actually a 4-digit number, so don't be fooled by how Excel displays things to you. And we also have a company column, the company that the complaint was against. More repetition, there can be more than one complaint per company, so here's 2 for Flagstar Bank. And then the company's response, whether it's in progress, close with explanation, close with non-monetary relief. And then over here, finally, we have, was it a timely response, and was it consumer disputed? Did the complainer dispute the company's response to their complaint? So with this, let's next draw out a data model so we have an idea of what we want to do. So again, like I said, every row here is a unique complaint, and I'm going to want to have a node for each complaint with its ID. And then I'll also want, remember the date is going to be per complaint. I want to have the date of the complaint on the complaint node, the date it was received. But Neo4j doesn't support date type objects, so I usually split it out into 3 separate properties. Year, and these will be numeric, these will be integers, month, and day. And I'm going to show how I split that column, that date column, up so that I achieve these 3 separate properties on the complaint node later. But that's something that I find myself doing constantly when I have a date and I want to put it as 3 separate numeric properties and filter on it later. So every complaint will be a node. I'm going to do bootstrap. And then I guess it didn't work. Every complaint has a company that it's against, so we'll point to a company node that has a name, Bank of America, for example, and we'll say that the complaint was against the company. So the complaint is against a company, and then there's also a response to the complaint. So we're going to recreate a response node that has a name like closed, and I think there was in progress on there. So each response node is going to be unique by the name of the response, in progress or closes non-monetary relief, and then so there will be a uniqueness constraint on that name property for each response node, and similarly for the complaint nodes, there will be a uniqueness constraint on this ID, and for the company nodes, they'll be unique by the name property, and that's going to be true for pretty much all the nodes I create today. But the per complaint part, whether or not the response, or in terms of the response, whether or not the response was timely or disputed, I'm going to go ahead and store that information on this property. So I'm just going to do true, false. Was it disputed? Was it timely? I'll just put those as Boolean properties. So the response, in progress or closed or whatever, to this complaint, was it disputed or was it timely? I'm going to go ahead and put that on the relationship. And then all the complaints have issues. So then I don't remember what one of the issues was, but the issue will have a name property. It'll just be the issue itself. I'm going to go ahead and call this with. So a complaint with this issue, and whatever the issue is called. And then a complaint is also about a product. And the product node will also have a name that it will be unique by. I'm going to say the complaint was about this product. So complaint against a company with this issue about this product. And we also want to do the subproducts with whatever their name is. I'm just going to go ahead and say it's about that subproduct as well. And similarly with the sub-issue, which will have a name property, I'm going to go ahead and say it's with that sub-issue. So again, this isn't a modeling webinar. I'm just trying to visualize what I want to do after looking through the CSV file, how I want to model this. So, and then I'm going to go ahead and model this relationship so that if I do want to ask the question, what are all the subproducts of some product, I just want to be able to traverse here instead of having to scan through every complaint to get that hierarchy, because that would be an expensive query for a simple question. So I'll go ahead and model that as well. And this is pretty much it. This covers all the columns that I want to deal with today. So complaint is against a company. There's a response to the complaint, whether it's disputed or timely, with an issue, with a sub-issue. And I think that pretty much covers it. So with this visualization, now we can start getting into how we're going to write the import query. But before I write the import query, it's always a good practice to ensure that what you think is in your CSV file is actually in your CSV file, because like I said, Excel might display things differently. Who knows, there could be weird characters you weren't expecting. So it's just good to go ahead and load it here into the browser, just the first row, and display it and see what load CSV is seeing. So I need to find this. I think it's in Nicole. And you have to limit one, otherwise you're going to have a bad time. So here's the first line from my CSV file. And we can see that the year on this date is 4 digits, and we can also see some of the columns I had hidden in my Excel spreadsheet. I had zip code submitted via hidden, but it's displaying it here. So here we're seeing what load CSV is seeing, and it's important to understand what load CSV sees versus what you see. So here I'm getting an idea of what I'm dealing with. And now I also want to troubleshoot how I'm going to deal with this date received. I know I want to split it up into 3 separate things, and that's pretty easy. I'm just going to make Cypher do the work for me. There's a trade-off between, cleaning things in, some programming language, cleaning up a CSV in Python or R or whatever, versus letting Cypher do the work for you. Here it's so simple. I'm just going to split on this /. I'm just going to have Cypher do the work for me. So I'm going to say, let's see. I'm going to get that date received column out, line.date received, and it's important to note if you have a space in your column header, you need to surround the name with backticks. So with line date received as date, I'm going to return the date. So here, this is just giving me a string. And I'm going to go ahead and split on this. This is something you'll have to do a lot if you want to have Cypher do any work for you. Split that on the date, or split the date on this / rather. And now that's going to turn it into a length 3 collection. And we can access those with indexes. So the first one is going to be date 0. The second one, date 1, so on and so forth. So with that, it'll be easy to split that up. So I'll set the month to date 0, I'll set the day to date 1, and I'll set the year to date 2. So in the first iteration, I'm gonna have Cypher do a little bit of dirty work for me. So with that, I just wanted to show the workflow of when I'm gonna have Cypher do something tricky for me, I'll just try it out on the first line and figure out how I'm going to do this part, and then I'll just copy paste it into like my big query that I end up doing later. So I've already written this part, so I'm gonna use the Cypher syntax. So load CSV with headers from the file path as line. This is the alias. So I'm going to say with line and this split as date. I'm going to, well, let me back up a bit here because I'm forgetting my golden rule already. So the golden rule to load CSV is to always make sure you have indexes on properties that you're going to be merging on, and to use periodic commit, because otherwise it will try to do it all at once, and that's no good. Using periodic commit is going to try to, the default is 1000, and you can think of it as committing every 1000 rows. And you can tweak this depending on your machine, depending on a million things that will depend on your specific use case. But I'm going to go ahead and use the default using periodic commit, load CSV with headers from this file path as line. But then before I even get into that, I need to do something really important. So all these nodes are gonna have a uniqueness constraint on them. The complaints are going to be unique by this ID. The companies will be unique by their name. The response will be unique by their name. And by creating uniqueness constraints, you also create indexes on those properties. So I'm going to create a constraint on the complaint nodes and assert that the ID is unique. For this first part, this first iteration through the CSV file, I'm just going to model this top part of the model. One, to show how easy it is to model incrementally. You know, I don't have to import everything that I've displayed here at once. Let's say I'm only interested in this part of my model for right now, and then later I want to go in and add in the products and issues, and I just want to show how incrementally it's easy to add data to your graph that already has data in it. So for this first part, I'm only going to do the complaints, the companies, and the response nodes, and of course their respective relationships here. So I'm just going to create their uniqueness constraints relevant right now. That will fail miserably on the company node. I'm going to assert the company name is unique and create a constraint on those response nodes. So I got those, and then I can start writing so this is going to be for complaints, companies, and responses. Comments in Cypher are //. So using periodic commit, load CSV with headers with the line and with the date split as date, I'm going to create a complaint node with an ID property complaint ID. And it's important to know that load CSV is going to treat everything as a string, literally everything. Even though this is clearly an integer, it's going to import it as a string. So you need to make use of the toInt and the toFloat functions in Cypher. So here I'm going to use toInt because they're all integers. So I'm creating a complaint node with label complaint that has this ID. It's an integer version of this complaint ID column. And again, I'm using backticks because there's a space here. So I've created that complaint node. And now I'm going to use the merge keyword because I want to find or get a company node that has the name line.company. There's no spaces, so I can just do line.company without the backticks. And I'm using merge here because, as we saw earlier, companies are going to show up more than one time as we iterate through these complaints because, of course, people complain about the same company, right? And we don't want to create a new node when this is encountered. We just want to find it. So on this second iteration, the flag star bank node will be created, and then on the next it will be found. And that's what merge does. It is find or create. So I'm going to merge on the company. So I'm going to create a find or get a company node with this name property, and I'm going to go ahead and uppercase it. I'm just going to uppercase everything because perhaps I don't really know much about this CSV file. It could be that flag star bank is capitalized differently elsewhere, and I don't want that to be treated differently. I want everything to be the same regardless of how it was capitalized. Mostly, and of course, you know, that's one of the trade-offs I talked about earlier. That would be a really trivial thing to do in Excel or in any programming language to uppercase everything, but it's just super easy for me to use upper within my import query, and that's what I've chosen to do. Of course, you can clean this up yourself before the import query so you can avoid using upper, but you cannot avoid using toInt because no matter what you do, load CSV is going to read it as a string. So I'm going to merge on the company, and I'm going to merge on the response type. So the response node, that would have been bad. So the line, what is it? Company response. And I'm going to uppercase that too. So here we've just created nodes, create, merge, merge. And now we're going to actually create the relationships that we talked about. So we want the complaint to be against a company, and we want the response to be to the complaint. So that was the top part that we talked about here, the company complaint response. And then recall that I also wanted to put these properties as, or the disputed and timely information as properties on this to relationship. So I'm going to go ahead and put an identifier here so that I can set properties on that relationship. So I'm going to set r.timely. I'm going to go ahead and use the case statement because over here in this column we have yes and no strings, yes, no blank, and over here we also have, I believe, yes, no blank. And I'm going to go ahead and make the assumption that only yes is true, blank or no is going to be false. So here I'm going to use the case statement. So case line dot timely response, I believe it has yes. Line timely response, when yes, then true, else false, end. So I'm doing a simple case here. When on the timely response column, when it is this string, then set our timely to true. Otherwise, set it to false. So when it's yes, set it to true. When it's blank or no, set it to false. And then similarly, for r.disputed, the disputed property on this relationship here, I'm going to use another case statement. So I'm going to do line.consumer disputed. Let me double check. Yes. When true, else false, end. Okay. And I think that should be good for my first iteration. So another thing to keep in mind when using load CSV is that you pretty much always want to use the shell. It's going to give you better error messages, especially if you have weird characters in your CSV file. It's pretty good at telling you which line has the problem, which has been helpful for me in the past. So if you're on Mac or Linux, it's pretty simple to start the shell. You just navigate here to where you have Neo4j, your Neo4j folder, and you do bin/Neo4j shell, and that should open it up for you. And if you're on Windows, you can do it a hard way, or you can do it through the browser, which I think the latter would be easiest for most. You click on this I thing, and then you go down to the Classic UI Web Admin, and you power through these pop-ups and Power Tool Console, and then you'll be able to talk to Neo4j through the shell. The only downside is that in my shell, I'll be able to copy-paste a bunch of queries that are delimited by semicolons, whereas here you will just get an error. You have to do queries one at a time. But I think it's better than the current solution of running the shell on Windows. So kind of a tangent, but I want if anyone is following along on Windows, just do this shell for now, because running it natively on Windows is a long process. So let me go back. So first of all, of course, I need to create these uniqueness constraints, because the golden rule with load CSV is don't use merge on a node and a property unless an index exists on that label property pair. So here I'm using merge on companies and responses, and you can check what your currently existing indexes and constraints by doing colon schema in the browser. So here all my indexes that I want are online, so that is good to go. And then if I do not have any syntax errors oh my gosh, I almost forgot to set the date. So I created that complaint node, and I wanted to set the date properties on it. So under here, I'm going to say complaint year is an integer version of date. It was the last one, remember. Complaint.month is an integer version of the first. This is American date, so it's all out of order. And the day was in the middle. So right, I've created that complaint node. I'm setting the year, month, day properties as integers. Remember, I split it into this length 3 collection up here. And I'm just kind of double checking here, looking for anything terribly wrong. But usually it's pretty good at telling me what's wrong. And the second golden rule, do I have using periodic commit? Yes, I do. So hopefully that works out. So this is the bulk of it, actually. So this will take a few seconds. While that's running, trying to fit it all on my screen here. While that's running, let's think about the next part that we want to do. So we just did company complaint response, and now say we want to add information about the products and issues. So now this next part, we're going to model the complaint being about a product and the complaint with an issue. So I'll go ahead and copy this part, and we see that the query finished in 42 seconds, and it created 300,000-ish nodes and 600,000-ish relationships. So that's good news for me. So I'm going to go ahead and copy this over, and I'm going to switch this to match, because for the second iteration, the complaint nodes already exist in the database now, right? We have complaint nodes now, so they already exist. I don't like that color. And we have the companies and responses. Hold on, I'm doing a bit of housekeeping here. So we have the complaint was against some company, and this is the response to that complaint. Here's the timely and disputed properties. This is a good way to ensure, of course, to go look to make sure your data made it into Neo4j. And we have the company, and then we have the year, month, day here that I expected it. This is what I expected it to be, so this all looks good. But my point is that there's already data in the database now. The complaint nodes already exist, so now we want to match on them. So we're going to match on the complaint ID. And for this next part, we want to create the product and issue nodes. And again, the products and the issues are going to show up more than once, so we're going to use merge there. And as I'm typing this merge keyword, I'm thinking, okay, I'm using merge. I definitely need to create an index on this property that I'm about to type out. So I want to create a product node, to find or create a product node with this name. And I'm going to go ahead and uppercase it. And I'm going to go ahead and write this out just so I don't forget. I want to create a constraint on product nodes and assert that the name property on the product node is unique, so that merge has an okay time finding or creating those product nodes. And similarly, for issues, assert iname is unique, because I'm also going to do that same thing for issue nodes. I'm going to create an issue node that has a name property of whatever column we're on, or whatever row we're on. and I believe, yeah, they're called products. Yeah, the columns are product and issue. I'm uppercasing both of them. So I've matched on the complaint. I've gotten the complaint out of the database, and now I'm creating the product and issue nodes, finding or creating. And now I'm going to create the relationship between the complaints and the products. I'm going to say the complaint was about a product, and the complaint was with this issue. And I think that's all I'm doing for this iteration here. I just wanted to add on those two nodes just to, again, to show how easy it is to iterate on your model. So first I'm going to create these, double check my spelling. Okay. And again, in case I want to be extra sure, I can't. I'm gonna check my schema. So product, issue are online with indexes. If you have a ton of stuff in your graph already and you add a constraint or index, it might take a couple seconds for it to be online. So I always go check to make sure that they are. And I don't need this part anymore. I don't need to split the date, so I didn't need to copy that over. So golden rules, do I have uniqueness constraints, or do I have indexes rather on the properties for nodes where I'm using merge? Looks like I do. And do I have using periodic commit at the front of my query? And I do. So if I cross my fingers, let me double check about product with issue. This should be good to go. And now for this next part, while that runs, I need to show how I deal with empty strings. So with an empty string, if you were to just naively go for it, you would be pointing at nodes that have an empty string as a property, and you don't want that. And there's no sense of null values in Neo4j. You can't have a node with a null value as a property. So I actually just want to skip these rows for modeling the sub-issue. So when a complaint doesn't have a sub-issue, it's just not going to have a relationship pointing to a sub-issue at all. So actually, in this next iteration, when I start adding subproducts and sub-issues, I just want to skip the rows that don't have sub-issues and don't have subproducts. And I'm going to do that separately, both for subproducts and sub-issues. So I already did this because I didn't want to have you guys watch me do this for like 45 seconds, but I just did this. It's so easy. I just did it in Excel. I turned on the filter. So from this drop down, I omitted blanks, and then I copied this column and this column so we could find which complaint it was into a new CSV file. And that is over here. And similarly so then I cleared this filter over here, and I similarly over here for sub-issues got rid of the blanks. I then copied this column and the complaint ID column, because again, the complaint ID column, I need that because that's how I'm going to find which complaint had this sub-issue. So I'm copying and pasting both these columns into a new CSV file, and that's the result of that. So now I have these two new CSV files, one called subissues.csv and the other called subproducts.csv. And I'm going to go through both of those now to model the sub-issues and subproducts. So I'm going to go ahead and copy this over. And I now have a different file name, so I'm going to switch that. I'm going to do the sub-issues first. And I can copy a few more things because I need to match on the complaint. So I'm going to match on the complaint that already exists in my database, and I'm also going to match on the issue that the complaint was with, since we also already added that. We just added that in the last query. Let's check on that actually. That took 16 seconds. only 88 nodes were created, but around 600,000 relationships were created. But that's because there are only a handful of products and issues, so it's a pretty dense node there. So right, so we just created the complaint with issue. So now I'm going to match on it because remember that I want to create the I deleted it over here, but I wanted to create the sub issue in category relationship. So that's why in this next iteration, not only am I finding the complaint, I'm also finding the issue that it was with, so that when I create this sub issue node, I can point to the issue. And the reason for that is more of a modeling thing, where if I, like I said earlier, if I wanted to write a query that just find me all the sub issues of this issue, then I should just have to reverse this handful of relationships. I shouldn't have to scan through every complaint to get that information. But that's beyond this beyond the scope here. So I'm going to match complaints. I'm going to match complaints with issues, and then I'm going to merge on that sub issue node. And as I'm writing merge, I'm thinking, do I have a uniqueness constraint? No, I don't. So create constraint on sub issue nodes. Assert that the S name is unique. So here I'm going to merge on that sub issue node because the sub issue, of course, will show up more than once. And it's called line dot something sub hyphen issue. And I'm not entirely sure how Cypher would deal with that hyphen, so I'm going to go ahead and use backticks just to be safe. And I'm going to uppercase it. So that will find or get the sub-issue node, and then I want to create that the complaint was with that sub-issue, and I'm using create here because I know it's unique, because every row is unique by complaint. I know I won't be creating this more than once, but on this next one I want to use merge because this will happen more than once. You will encounter the same sub-issue and issue pair in the CSV file, and so you want to use merge so that it will only create this relationship if it doesn't exist yet. So I've matched on the complaint's issue, I've merged in that sub-issue node, I'm creating that the complaint is with that issue, and then I'm merging this categorical hierarchy type stuff that I want to keep track of. So let's copy that in. Let me double check everything. I have the index online now. I have using periodic commit at the front. Load CSV with headers from. This is hopefully the correct file path. I'm just checking for typos at this point. Upper line. Issue and category. Issue. That looks good to me. So go ahead and do that one. And next, that took 6 seconds, so that's pretty good. But of course, it's a subset, so it looks like there were only 84,000-ish complaints that had sub-issues, because that's the only, those were the relationships created. Actually, there's going to be a bit more for this relationship too, but around 84,000 probably had sub-issues, so that was pretty quick. And then I'm going to copy-paste some more. So for the sub-products, we're going to match the complaint again, of course. We're going to match the complaint is about some product, which we've already added to the graph, so we're finding it from our database, and then we're going to do pretty much the same exact thing here. We're going to merge sub-product on this name property, sub-product, and again, I'm not going to stop saying it. You need to create an index anytime you use merge. Okay. Create constraint on subproduct, assert the name is unique, and then I can use merge. I'm going to create a subproduct node, find or get with this name property, uppercase version of the subproduct column from this CSV file, right? And then I'm going to say create the complaint about that subproduct and merge subproduct in category product. And oops, that should be good to go. So this is pretty much the same, so I'll just get it going here. So I need to add that constraint, double check that I have the right file path, double check that I don't have anything silly, upper line subproduct, complaint about. Okay, so this should be similarly quick, I think. And then with that, we have everything that we initially drew out over here. So yeah, again, I mean, I just want to show that there's a trade-off between using, doing your own manual cleaning in Excel or Python or whatever you use versus letting Cypher do some work for you. It's just more whatever workflow you're comfortable with. I'm very comfortable with Cypher, so I let it uppercase things for me and split on forward slashes and stuff like that. But then when you get into stuff that's maybe a bit more complex, you'll find pretty soon that maybe it's easier if you're not as comfortable with Cypher to do yourself with any programming language of choice to maybe clean up or manipulate your CSV file as you see fit to avoid doing anything really sticky with Cypher. But as you saw, this was pretty trivial for me to create these two new CSV files so that I could avoid those empty strings that were in this original CSV file. So it's just however you want to go about it, really. So that should be done. And of course, you want to ensure your data was uploaded as you expected it to be. So I'm going to go ahead and find how many complaints there were. So it looks like there were 310,933 got uploaded, and let's check. That might blow up my computer actually. Oh, I didn't have a filter on. Okay, never mind. But that's how many were in the CSV file because I already looked at it. And right, do we have more time, Greta? Well, that is all I have. I will include you can find the code for all of this if you want to reproduce this on my GitHub. Go to github.com/NicoleWhite/consumer_complaints, and you'll be able to recreate this yourself if you want. Thank you.